Okay, consider this example. We have a 75 kilogram red painter that's standing at the center of a 50 kilogram, the blue one here, 3-meter plank. So its mass is 50 kilograms and its length is 3 meters. The supports are 1 meter from each edge. So we have support A here 1 meter from this edge and support B 1 meter from this edge. So what's left here is another meter, and the painter is standing at the middle. Okay, the question is calculate the force on support A. So the force exerted by this support. To work something like this, so this is something in equilibrium, which means the sum of all forces is equal to 0. But since our plank here can rotate, the sum of all torques is equal to 0 as well. So we draw a free body diagram. Free body diagram, but in this case, we are going to draw the plank. We are going to draw the plank because the pivot is going to matter. So this is my plank. So what are the forces acting on it? We have the force exerted by B. Let's call it FB. The force exerted by A, let's call it FA. Then the gravitational force acting on the plank, so FG plank. And then the force exerted by the painter feet on the plank. Okay, what that force is going to be equal to, so we are going to do a mental calculation here, because there are no other forces acting on the painter other than the gravitational pull of the earth on the painter. So if we consider the painter for a second, the forces acting on it, the gravitational force acting on him, and the normal force exerted by the plank on him. So these two forces, since the painter is in equilibrium, are going to be equal in magnitude. So the normal force is equal to the gravitational force in this case. And the reaction to that normal force is the normal force that the painter exerts on the plank. And that's what we are interested in. So it's the force exerted by the painter on the plank. But we know in magnitude that's equal to Fg of the painter, the gravitational force on the painter. So these are my forces. The next thing is to write Newton's second law of motion. Newton's second law of motion says the sum of all forces is equal to 0, which means Fa plus F and P plus FGP plus FB is equal to 0. Now, of course, it is helpful here that all the forces are along the vertical, so I don't have to worry about components of forces. Everything is along the vertical. So if I rewrite this equation with the upward direction being chosen as positive, I have Fa minus Fnp minus Fgp plus Fb is equal to 0. Now, obviously, this is not sufficient to solve for Fa and Fb. We have two unknowns and one equation. So then we resort to the torque equation. The sum of all torques is going to be equal to 0. That says torque due to Fa plus torque due to Fnp plus torque due to FGP plus torque due to FB is going to be equal to 0. To be able to calculate the torques, I have to choose a pivot point. And of course, we can choose the pivot point anywhere we want, but by choosing the pivot point at the right location, we can make our task a little easier. For example, the question here is not asking us about f sub b. So if it is not asking us about f sub b, it might be convenient to ask for to select the pivot at the point B here, where the support due to B is touching the plank. So if we do that, then the torque due to FB is equal to 0. Okay, let's change the color of this. So the torque due to FB then becomes equal to 0. Now, what's the torque due to FA? Notice FA is pushing this way. This is my pivot. So FA is going to rotate my plank in the clockwise direction. This is the line of action of A. So this is my lever arm. So torque due to FA is going to be minus is because it's clockwise. FA times the lever arm is 1 meter. 1 meter. Okay. Now what's the torque due to FNP? The torque due to, it's not liking to write. Okay, let's write it here. Torque due to FNP. So it's going to be FNP, which is the mass of the painter times G. Times the lever arm. Remember, the line of action here is this distance, which is half a meter. So times 0.5 meters. And the sign is positive since, relative to this pivot point, the fact that the force is pushing down this way tells us it's going to rotate the plank in the counterclockwise direction. So that's positive. Similarly, the torque due to FGP is going to be FGP times half a meter. So when I write the sum now, it's going to be, so it's minus FA times 1 meter. That's torque due to FA. Torque due to FNP, that's plus 75 kilograms times 10 newtons per kilogram, that's G, times 0.5 meters, plus 50 kilograms, that's the mass of the plank, times 10 newtons per kilogram, times 0.5 meters. Okay, so let me use the eraser a little bit so I can write in a place where we can see. So then that gives me FA is going to be equal to 75 times 10, that's 750 times 0.5, plus 50 times 10 times 0.5. So this is 75 plus 50, 125 times 10, 1,250 times 0.5. 1,250 times 0.5 over 1 newtons. So that gives us 612.5 newtons. That's my force. Now, if I need to find the force exerted by B, I just replace this here, and I know everything else, so I should be able to solve for FB.